Okay, welcome everybody to the Open Wallet Foundation Wallet Interoperability SIG for November 10, 2025. Today's agenda is going to be a little quick up front, and we're going to get right into the presentation because it's just Bo and I today, and I have to run to a train. But we have Keith Kowal and Alexander Shenshin joining us to talk about an update on the Hiero did integrate identity integrations with Open Wallet projects, and we're incredibly excited that they're here to give this presentation. But before we start, as with all Linux Foundation meetings, this is held in the Linux Foundation antitrust policy / competition policy. If you have any questions about these matters, please contact your company counsel, or if you're a member of the Linux Foundation, feel free to contact Andrew Updegrove of the firm Gesmer Updegrove LLP, which provides legal counsel to the Linux Foundation. In addition, this is held under the Linux Foundation Code of Conduct, which can best be summed up as be excellent to each other, be kind to each other, just be cool, and we're going to get a ton of work done. And we thank you all for joining us today. This meeting is being recorded and may be posted and will be posted to the OWF YouTube later today. I'm going to have to leave early to jump on a train, then I'm going to get it up on YouTube when I get home. If you'd like to present to the Wallet Interoperability SIG, we have a sign-up sheet, and you will see before the end of the year. First of all, there's no meeting the week of December, well, Monday, December 1st, because of the Thanksgiving holiday. And we've got 3 open slots. So if you'd like to present your project, your work, what you're working on, it doesn't have to be an Open Wallet Foundation project. We actually focus on at least 50% of our time talking about things outside of the OWF because we need these ideas to cross-pollinate, and we want folks bringing new ideas into our community. We want to share with them what we're doing. So I cannot thank you all enough. This is also a link to the Wallet Interoperability SIG playlist. And you'll see, last week's EUDI business wallet with the Severity team. They were here and they did a great job. Is there anyone new on the call who hasn't been here before who'd like to introduce themselves? All righty. Well, I know all of you, but that doesn't mean everybody knows all of you. But thank you all for joining us today. This is an artifact from last week, but once again, I'd like to thank Shar Howland. She has been a fantastic co-chair of the SIG. She and Bo were leading it. I'm working right now and getting another co-chair to work with Bo. But I'm happy to leave this one up there as forgetting to delete it. Char's a rock star, and she will be missed, but she's always welcome back, and she's a part of our community, even though she's moving on to work on other things. Upcoming Wallet Interoperability SIG meetings next Monday. DCC, Learner Credential Wallet. This is the team from MIT. They're really focused on academic credentials, but also if you've ever seen Dimitri Z present at IIW or DICE or another big industry event, I wish I had him as my comp sci teacher. I probably would have got a comp sci here. He's awesome. And then 11/24, the WeBuild team is going to talk about WeBuild and organizational wallets. Immediately after this call, at the top of the hour, I don't know what hour it is where you are, the Architecture SIG is going to meet for 30 minutes to talk about what's next and what they're working on. A lot of this work is around the mapping effort for Open Wallet Foundation projects, understanding the commonalities and dependencies that all of our projects have, which Romek has been doing a kick-ass job combing through our GitHub, but really, working on how we can all move forward together even faster. From a project update perspective, I don't have updates because I didn't run around, but I do see Stephen Karan here. Stephen, is there an aca-py update you want to give us? Putting you on the spot.
Sure. 1.40 will be out this week. There was some final cleanup done and work done and testing on the RCs, and we will get the 1.4 release of aca-py out this week. So that's the update on that.
All right.
Also, I'll throw one more thing out. Lots of work done recently on didwebvh server and getting that implemented, deployed, user-friendly, and really makes it a lot easier to deploy a solution with didwebvh. So, and that combines with aca-py, Credo, and so on.
Cool. All right, and with that, I'm going to stop sharing. I'm going to turn it over to Alexander and Keith, and Bo, I'm going to make you the host, and then I'm going to get to watch this after I post the recording to YouTube. But I want to thank you all for joining us today, and I will see you all later on the recording. Alexander and Keith, it's your show, please.
Thanks, Sean. Give me a second to share my screen. Can you see it?
Yes.
You're looking.
Great. So yeah, welcome everyone. My name is Alexander. I'm a lead software engineer at DSR Corporation, representing the Decentralized Systems Department team. I will be the speaker today along with Keith Kowal, Director of Product Management at Hashgraph. And we're going to give you an update on Hiero decentralized identity integrations with Open World Foundation projects. Yeah, first of all, I have some assumptions about audience members. Sorry, just like I don't feel we should talk a lot about basic concepts here. First of all, it's knowledge about the IDs, verifiable credentials, and verifiable data registries, and basic knowledge about cryptography, hashing, etc. Also, two last points, just basic knowledge about unencrypted credential formats and some degree of familiarity with aca-py and Credo Open World Foundation projects. Just in case, if needed, I can put a small comments on last 2 points. So if anybody feels that it will be useful, please raise your hand. Okay, yeah, I thought so. Talking about agenda, what we're going to talk about today. First of all, a short overview about Hiero and Hedera Ledger in general. Then we will move forward and talk about Hiero decentralized identity ecosystem specifically. Then I will give a short overview of Hedera, aca-py, and Credo plugins. So these are separate projects, of course, but they share similar concepts and integration logic. So it's kind of joint overview. Then we will go a bit deep into technical details about plugins architecture and integration with Hedera. Then I'd like to show you 2 demos, one for aca-py plugin and second one for Credo. These are recorded demos for convenience. And then we'll briefly talk about what are the benefits for community that we see here and our roadmap and what's next. And let's start with Hiero and Hedera overview, and I'd like to give a floor to Keith here.
Yeah. Thank you, Alex, and thank you everyone for letting us join today and present. So some of you may or may not know Hedera. So Hedera is a layer 1 blockchain that kind of has a unique architecture. And we made the decision a while back that we've been open source for a long time, but we actually have moved all of our code base into the Linux Decentralized Trust and that project is called Hiero. So today, all of our code and the code that we'll be discussing today lives in Hiero, again, under Linux Foundation Decentralized Trust. And so it's all open source. It's all governed by Linux Foundation. And yeah, and that's the spirit of what we've been working on. Next slide, Alex. So yeah, just again about Hiero. So a Linux Foundation Decentralized Trust project, and I'm going to assume that most of you are familiar with Linux Foundation, but I think that there's more and more projects coming to at least Linux Foundation Decentralized Trust. Some in the identity space, some in the blockchain space, but obviously trust over IP has gone over there. So yeah, we have a lot of great company, and I think we're going to have more and more in the future. Next slide, Alex. So yeah, I mean, in terms of the layers of the Hedera ecosystem, so again, you have Hiero. Hiero, I mean, for those of you who have been in the blockchain space before, you think of Hiero as something like, Hyperledger Fabric. It is an open source implementation of both the blockchain, but also everything, all the things around the blockchain, all the services around the blockchain, they're all open source. And then Hedera basically is an implementation, or commercial public implementation of that open source standard, which we call Hedera. And that's the layer 1 blockchain that I work on, and my colleagues at Hashgraph, we maintain and do the marketing for the Hedera network, which is a blockchain out there that, like many other blockchains, you can do things like we have a cryptocurrency called HBAR. You can do tokens. You can do smart contracts. It's a general purpose EVM blockchain. And then, of course, on top of that, on top of the Hedera blockchain, you have apps that are built on Hedera, whether those apps are identity, like we'll discuss today, or for ESG, like the Guardian project, or around asset tokenization, around creating NFTs. So we have lots of different projects that are built on top of Hedera. And so this would be like that third layer that we'll be discussing today, that the application layer built on top of the blockchain, or leverages the blockchain. Yeah, just Hedera. So Hedera is a open source proof of stake public network. We have a little bit unique structure in that, you know, maybe unlike Ethereum, we have today like 32 nodes, council nodes, which are run by Fortune 500 companies, and they operate our consensus nodes. You know, it's a very high throughput network. It's very low cost. One of our other distinguishing features about our network is that all the fees are based in USD. So that means like a lot of different blockchain networks, you get a lot of variability, like if the Ethereum or Bitcoin price goes up and down, but you don't have that on Hedera. So Hedera was really kind of built from the ground up as like an enterprise-friendly public blockchain. And that was one of our key characteristics, is that like if you're building an application on Hedera, you don't need to deal with variability of costs. So, and there's a lot of other features like that, but I was just kind of calling out one that I think kind of sets us apart. So in terms of Hedera, like I said, we have the governing council, and we have at the bottom there, we have the core of it all is the hashgraph consensus algorithm. That's how the different nodes come to consensus on a transaction. And we are, I think, one of the only blockchains that's ABTF. And then above that, built on top of the consensus layer, we have different, what we call services. And we have things like the token service, that's for creating fungible tokens or non-fungible tokens. We have a smart contract service. But one of our differentiating services, which we'll talk more about in today's presentation, that we build a lot of our identity stuff on, is a very unique service called consensus service. And I think we have other slides on that. Yeah. So the consensus service is this really unique service where anyone can write a message on Hedera up to 1024 bytes, and that message can have any content. And so the structure of this is that you have a topic. You first create a topic, and then underneath the topic, you can have any number of messages. And so when we talk about things like deploying DIDs on Hedera, or deploying or anchoring DIDs on Hedera, or anchoring other, let's say, non-cred objects like, you know, the cred defs or something like that. Or in the future, if we talk about like maybe other identity constructs, like, I don't know, zero knowledge proofs or things like this, this is the service we use to anchor those identity transactions on Hedera. In the case of, like, I think many of us are familiar with DIDs, like for a DID, you would do when you create a DID, you would write that as a message underneath the topic. When you update a DID, you would, you know, likewise write a message. And then when you deactivate a DID, you would write a message. And then anyone wanting to know the state of the DID would basically read all of the messages underneath the given topic and then kind of reconstruct the state of the DID. And they can do that on their own. And of course, Hedera being a public blockchain, we have all the great characteristics of a blockchain. We're immutable. We're extremely horizontally scalable, like anyone can read the data. And probably most importantly, when it comes to identity, you know, we have from a privacy perspective, you cannot correlate. Like you cannot see who's reading the information about, let's say that in my example, a DID. So the author of the DID or an issuer cannot see who's reading the information, and that's what maintains like privacy between issuers, verifiers and issuers. And so, I mean, that's a key characteristic. But another one would be like just you know, for something maybe more like zero knowledge proofs, you can anchor things like your Merkle tree root or things like that. And it's highly readable, very horizontally scalable, and yet no one can see who's reading it. Next slide. Yeah, and just in terms of our ecosystem, so, you know, as a blockchain, we've been around for a while. A few years ago, we have a process called a HIP process, or Hedera improvement process, where anyone can kind of suggest improvements. And a few years ago, we had the suggestion from the community that they wanted to see work on supporting a non-creds with Hedera. And so that HIP was approved and we went forward. And the first thing we did was we did work last year. We did a aca-py plugin with Hedera. And then this is the continuance of that work where we want to do integration with Credo and with Bifold to complete that kind of work to make sure that we have a robust ecosystem for non-creds, but also we have obviously a lot of projects on Hedera also integrating with the OpenID standards more broadly. And so this is just kind of a timeline of the history. We've had a did Hedera on Hedera for a while. We introduced the non-creds method in 2025. We just had an update to our did method, again, proposed by the community. So that just happened. So yeah, just a lot of activity and then a lot of different platforms integrating either support for did Hedera or Hedera integration, Hedera support in other ways in their platforms. I think that's it, Alex. I think I passed it back to you.
Yeah, thank you, Keith. Yeah, I will just continue with decentralized identity overview further. So yeah, here's the timeline. What I want to go back for a second and just give a brief overview of ecosystem components. So we have specifications, Hedera DID and non-creds mentioned by Keith, and one of the most important parts we have decentralized identity or DID SDKs, implementations of these specifications, Hedera DID and non-creds, currently available for Python and JavaScript, TypeScript. These SDKs are focused on providing high performance with special attention for read operations and caching strategies. Since we're using HCS, it has some specifics providing great capabilities, but still SDKs provide great benefit for performance since we're reading messages.
So we're trapped in a world of acronyms. So HCS, just I mentioned before the Hedera Consensus Service, or in short, HCS. Sorry, just in case.
Yeah, thanks. Good point. And finally, we have integration plugins currently available for Open World Foundation aca-py and Credo. So if we talk about higher decentralized identity availability, so here are some different layers. So as a storage and a blockchain ledger, we have a Hiero ledger. As for tools, as I mentioned, we have SDKs available for Python and JavaScript ecosystems. For server-side applications, we can use Open World Foundation aca-py or Credo-based applications. And user applications, we can use web UIs, which integrate with aca-py or Credo frameworks, Credo-based agents, and we have mobile wallets. Great example is Open World Foundation Bifold, which supports Hiero and Hedera through Credo plugin. And other Credo-based wallets. And there is also, you may know, there's PyIdentity wallet built on aca-py, which is mobile wallets based on aca-py, which is great. This was not present before in recent years. And let's move forward to overview of plugins. I will give short overview of plugins themselves. First of all, aca-py plugin. So it's basically an aca-py plugin providing components and integration of Hedera DID method in an non-creds registry and agent. It's built on top of Hiero DID SDK that contains Python implementation of these specifications, and it's contributed directly to Open World Foundation aca-py plugins repo. And if we talk about internal plugin structure here, just the basic stuff, we will go rather quickly here. So we have a common module which contains plugin setup that registers Hedera DID and non-creds implementations within aca-py instance. Also registers custom endpoints for Hedera DID registration. Contains some helpers as well, and we have two main functional models, Hedera DID and non-creds. For Hedera DID, we're implementing aca-py interfaces, of course, integrating. And we have a custom implementation for Hedera DID registrar. And for non-creds, the same, we're implementing aca-py interfaces, and we have some non-cred specific utilities there. And let's see a similar review for Credo plugin. A Credo plugin is similar. It provides integration of Hedera DID method and non-creds registry in Credo agent. It's built on top of newer Hiero DID SDK JavaScript that contains TypeScript implementation of the specs, and it as well contributed to Open Vault Foundation Creator repository as a separate package. Here we have slight differences in internal structure. We just have a header ledger module that is a separate layer for integrating with Hiero DID SDK.js used across the plugin, which also implements publisher and signer interfaces internally, which are supported by DID SDK that provide better flexibility, and also integrates, the important point, integrate with new Credo key management system API, which is more complex than before, but provides great flexibility and security properties. And we also have DID and Anacruz modules that implements required interfaces for agent integration. And talking about plugins architecture, it's a general example of aca-py agent and plugins there. So plugins enable standardized extensibility without overloading the core code base. This feature is fully leveraged by both plugins in header integration. And this diagram reflects aca-py integration as an example. So for aca-py agent, we can have multiple DID method plugins, for example, checked, did-webvh, and Hedera. And Hedera plugin registers implementations of Hedera DID resolver and Hedera DID registrar, which are directly integrated with Hedera network. And it all works very good inside of aca-py agent in modular plugins architecture. And the similar is for Credo. A bit of technical details on integration with Hedera network. So this is the diagram of under the hood integration. It's similar for both SDKs, Python and JavaScript, and it's leveraged in both plugins as well. So here we have three main layers. Hedera network layer, where we use HCS, Hedera Consensus Service, and another important part is Hedera mirror nodes, which, by the way, greatly contributes to Hedera scalability for reading operations. So we're reading data from there, basically. We also have our implementation in SDKs, Hedera Consensus Service Integration Module, and public API exposed by SDK. The most important parts here are we have HCS topic service. So messages on HCS are organized in topics. So we have a separate module that submits topic create and update transactions and also can query topic info. We have HCS message resolver, which uses topic messages query to subscribe to topic messages stream from Hedera mirror node. So basically, we're writing messages to HCS, then we have a process of data propagation inside of Hedera network, and then we're reading the messages using HCS message resolver module. We also have a separate module for submitting messages transactions. And an interesting part here, which is very important for unancred method implementation, for instance, is HCS1 service. So HCS1 is a standard on storing immutable files on Hedera Consensus Service. It includes mechanisms for data integrity control. So the immutable data is written to a separate topic on HCS, and topic information contains metadata about the hash of the data, so it cannot be changed. And a topic is also immutable and cannot be deleted. So there is no way to push new messages there. And there are data integrity checks, as I mentioned. And there is no way to delete the topic, basically. So it's immutable file or arbitrary data storage on HCS. And why it's important? Because it implements data chunking. Since HCS message itself supports very small message size, 1 kilobyte approximately. Next is about Hedera DID management and what parts of HCS integration module are used there. So here we have two main components for DID state management. Basically, we have the DID class, which encapsulates CRUD logic for operations. So how basically the DID is written to HCS, we're writing event messages for create, update, and delete operations on DID documents parts, basically services, verification methods, or other verification relationships. And each this event is written on HCS as a separate message. And then the SDK reads the messages and processes them, reconstructing the state of the DID document. This mechanism is greatly benefits from caching strategies, and also, yeah, and by the way, each DID is stored in a separate topic, also for performance reasons here. Sorry. So yeah, this DID model basically uses HCS message resolver, submit transaction, and topic services for managing such CRUD event messages for each DID document, and then resolving the state. As for aca-py integration, it's a bit more complex. So of course, we have a main component here that we have is Hiero aca-py registry, which manages aca-py resources such as schema, credential definition, revocation registry definition, and revocation registry entries. And the interesting part here is that schema, credential definition, and revocation registry definition stored as HCS1 files. So they leverage HCS1 standard and stored as immutable data on HCS. So the process is quite simple here. But for revocation registry entries, there is a different approach because we need to read them efficiently. And of course, we need to push new entries. And here we're using, well, different approach with writing each revocation registry entry as a separate HCS message, also using a compression. And since HCS provides also great capabilities in API for reading messages by a timestamp, by a different place in time, we can really quickly and efficiently retrieve revocation list state for given timestamp, which works really great thanks to HCS here. Okay, does anybody have any questions up to this point?
Feel free to ask questions about this very impressive progress, everyone.
Okay. We also have, okay, David, go on.
David?
This has been very, very interesting up to this point, but I wanted to try and go up a level. And could you say what the dominant use cases are for Hedera at this point in time, given you've already got an established public network with a stable currency as part of the transaction? What are the problems you're solving with it today?
And just to be clear, David, you're talking beyond identity. You're talking about all applications.
Yeah, just generally. I mean, if identity is relatively new in your context, but it's clearly got universal relevance, and I just wanted to hear what the dominant areas of focus are.
Yeah, so we have a lot. We're a general purpose blockchain, so we have a lot of different use cases. So I'll just call it some of the bigger ones. And just maybe I'll clarify identity. We've been doing Hedera has been on the network since 2000. So we're not new to the identity game. But this is just continued improvement. In terms of other use cases, so obviously we have a large project called Guardian, which is around ESG use cases, around things like carbon sequestration audit records. And that project actually highly leverages verifiable credentials and DIDs around how you do audit logs around carbon, like a farmer plants something, how you record all that information. And that the end result of all those audit records is that you mint a NFT, which is a carbon credit. So it means that for every carbon credit, you can go back and see the history of that carbon credit and see how it arrived to being a carbon credit, because there's a lot of fakery in that industry. So So that's one utility. That's a broad use case on Hedera. Another one, stablecoins is obviously a very exciting area right now. So there's some stablecoin activity on Hedera. Like particularly, there's a project right now in Australia around stablecoins. Stablecoins, asset tokenization. That's the concept that you take a building or a piece of land and you can turn it into represented as tokens, which could be bought and sold, kind of like as shares in the property. But instead of like pieces of paper representing the shares, you actually do it using tokens. That's another use case. So I would just say maybe one of the big use cases for Hedera Consensus Service. This was a big use case for many years, was around supply chain mechanics. So like every time we had a large customer, every time they would print a label, they would create an HCS message. Again, it was around auditability of their process. So many different initiatives, David, that they use the general purpose capabilities of Hedera.
Great, thank you very much.
Thanks, Keith. Okay, let's move forward. I think we also have a small time slot for Q&A in any case, for more general questions as well. So now I'd like to show you two demo recordings. First one is about aca-py plugin. So it's a console app demo of aca-py plus Hedera plugin, very similar to existing aca-py demos. It includes full unencrypted verifiable credentials flow with Hedera did, issuance, verification, and revocation. And this particular demo is a part of plugin code base, so it can be found here. Here's the link. Feel free to find it and try it yourself if you want later. And the second one that I will be showing is for Credo plugin. This demo is new. aca-py plugin demo was showcased before on community at least, and for Credo it's a new one. It's Hedera Credo plugin demo leveraging these are developed applications that use Credo under the hood. It's mobile holder plus issuer verifier agency backend. This demo includes verifiable credentials, issuance, and verification for unencrypted and SD-JOT verifiable credentials with issuer DID anchored on Hedera. And probably interesting to note is that applications used in the demo are planned to be released as part of open source project in future, but not open source at the moment. So give me a second and I will reshare my screen with demo recordings. Okay, here we go. Can you see it?
Yes.
Yeah.
Great. So here we have two console applications connected to aca-py agents with Hedera plugin. On the left side, there is an issuer and verifier agent, and on the right side, there is a holder. So it's interactive demo. First of all, there is some issuer setup, of course, for registering DID. You can see on the left console, registering DID, schema, and then credential definition. It takes a bit of time. And after issuer completes the setup, it actually generates connection invitation. So we're using DIDCOM. So now issuer application will complete the setup, and here we go, and output the invitation. So in this case, we're going to just copy the invitation to the right console app. But of course, in real life, it's transferred using QR codes and other methods. So here we established connections. Now we're going to send some messages using simple message protocol just to show that connection is working fine. Yeah, here's the test message for issuer, and then issuer will send test message for holder. And right after that, we're going to issue a credential. So this action is initiated from issuer side using issuer menu and automatically accepted on holder side. So we can see accepting credential offer, storing credential logs, and here is the stored credential data. You can see that all unencrypted objects, schema, credef, revrec they are using Hedera DIDs on a testnet. And now we're going to send proof request, of course. Yeah, so it happens rather quickly. So you can see that proof is valid true on an issuer side. And then we're going to revoke a credential and re-request the proof to showcase this functionality. So we're revoking credential on issuer side. We can see the credential has been revoked. And then we're going to request a proof again, and we can see that proof is not valid anymore. And yeah, for aca-py, that's it for the demo. It's pretty short. Do you have any questions on this one?
Maybe I'll take this opportunity just to touch on the economics of this, because I think that's important in the identity space. So in this example, we saw the creation of like topics. That's when like the startup happened. And then we were like writing messages, 8 messages to Hedera consensus service as the demo progressed. So just in terms of pricing, to create those topics is 1 cent. And then to actually write messages, like we said, when you create a DID, you write a message. When you update a DID, you write a message. Those cost decimal 3 zeros and then 8. So, one of the benefits of Hedera is that like this activity is very inexpensive. Also, as I mentioned, the pricing itself is consistent, and then it's always anchored in USD. And then it's very high throughput. So we've had, we can run Hedera consensus service up to 10K TPS. So, that meets, and we're continuing to scale that. So that means that no matter what kind of use case you're building, whether it's like a smaller enterprise use case or a larger government use case, it's highly scalable.
But every transaction has a fee.
So every write has a fee. Reads are, the whole nature of identity though is that most of the, there's very few writes and then there's lots of reads. So reads are free and anyone can read from any mirror node for free. The writes are what we charge for. And yes, it's typically once the setup is complete, it's it's decimal 0.0008 cents per write.
Okay, thank you.
All right.
Thanks, Keith. These are great details, pretty important ones. Yeah, I'll already switch the demo to the Credo. Sorry for that, for rushing things a bit. We just have a limited time. So this demo includes more complex, more advanced user UIs, as you can see. So here we have 2 parts. On the left part here, we have Hiero identity portal, basically. As I mentioned, it's built on this developed agency and will serve as issuer and verifier for this demo. And on the right part, we have also a mirrored screen from a mobile wallet, based on bifold, by the way, just heavily modified. We have our issuer account basically in Hiero identity portal. You can see some metadata about issuer. It's DSR issuer, DSR demo user. And we're going to issue some credentials. First of all, we're selecting protocol type and credential formats. It will be uncreds first, and we're selecting Hedera DID. Then we need to select a schema. Here we have some simple schema for the demo. These are demo credential. And yeah, we just need to fill in fields. You can also see a summary of issuance parameters, schema, protocol, and DID. And we generate credential offer. So this credential offer also contains DIDCOM connection invitation. So we're scanning a QR code. First of all, making a connection. And on mobile wallet, we're going to wait for credential offer to be received. Takes a bit of time. Yes, so now we can view our credential offer, accept it, and wait for credential to be received. Yeah, on completion screen, you may saw the credential schema name and issuer name, basically. These are the credential issued by DSR and here as well in credential card. And then we're going to issue another credential using OpenID for VC protocol and SDJOT credential type. So we're going through similar steps here, selecting header edit, going to select a schema as well, and fill in some data. And of course, we will see that OpenID issuance process is quicker. So you can also see that QR code is less complex, contains less data because OpenID for VC is connectionless. Basically, just a less technically complex process than using DITCOM. We're accepting this credential. So now we have two credentials, unancreds and credential issued with OpenID for VC protocols is DJOT credential. And then we're going to move to verification part. So here we have two templates. Basically, it's the feature of this Hiero identity portal. We could do similar thing for issuance. We can predefine parameters for issuance or verification. It just was left for explicitity for an issuance. And now we have just two templates for unancreds and for SDJOT and for OpenID. SDJOT verification, and now we're going through the process of verifying both. So currently we're waiting for proof request for unancreds credential, also of course delivered via DITCOM. It's DITCOM proof protocol basically, of course. So we can see that we just verified unancreds credential and we can see our credential data on verifier side. And now we're going to verify SDJOT credential in a similar way from verifier perspective. Yeah, here it is. And yep, we just verified both credentials and we can see that verifier received all the data. And basically that's it for this demo as well. Do you have any questions about this one specifically? Yeah, as I mentioned, these applications are not open source at the moment, but they're planned to be open sourced in the future. Go on, David. Sure.
It's a specific use case. A lot of the people we serve, individuals, may end up working with multiple ecosystems where they have to provide the same information, but in different credential formats. Could you set it up so that it would issue both types of credentials simultaneously as a concatenated step rather than having to go through that cycle twice? Could you multi-select which credentials you wanted in what formats?
Yeah, it's an interesting point. Not at the moment. I think it can be implemented, of course.
Okay, Stephen had a question here. Stephen.
Sure, I'll comment on the last one. The protocols, the DITCOM protocols do allow for that sort of thing, and there are techniques to use. Generally, the use of the goal code is used to indicate to the, can be used to indicate a complex stream, but I would also add the work that Dave McKay has done with VerID with workflows over DITCOM is really powerful and could be used for the type of thing you're talking about, David.
Thank you.
We should get him over to talk on this group because it's his work is really powerful. The question I was going to ask, and the reason I put up my hand was just Alexander, you touched on this. It was the open source and the contributing updates back to Bifold. Just wondering what the plan. Were you planning on doing that? Sounds like you were, and sort of the approach to take.
You mean for mobile wallet, right?
Yeah. Yeah.
You mean not really the Hedera integration itself, but the UI changes and so on, or you mean Hedera specifically?
Well, the Hedera specific's already there. I think that can be used just by pulling in
Yeah.
Credo. No, I was just wondering, you mentioned other verifications and other things. Are there specific things you're thinking of pushing back into bifold that might help the broader community?
It's a good question. So I would say that functionally, bifold already can handle OpenID protocols, of course. So in our wallet, we have a bit different approach, but I don't think that, I'm not sure. We need to think about it, actually. It's a good question. So I can't immediately name, for example, features that I know that we would like to contribute. And I just need to also double check what bifold cannot do and what it wants to do as a project. Because we have some unique features in this wallet, but I'm not sure that bifold community actually need them. So it's a good topic for discussion.
Maybe I'll just call out separation of concerns here for people. I know Stephen probably knows this, but this wallet, I mean, Alex, is a product from DSR. So I think now when we're talking about contributions, we're talking about contributions from DSR to the bifold wallet. This demo is really just we're using a DSR wallet to show off the functionality that we've integrated through the Hedera plugins, just in case anyone's kind of needs to understand those separations.
Yeah, I totally appreciate that and understand. I'm always on the listening for people who have essentially forked an open source repo, and I always hope to hear that they have a strategy for contributing back where appropriate, because I see so many good things that can't be accessed by the rest of the community. So always encourage structuring forks of open source projects so that they can be reused. It's always helpful. Yeah.
But here I also want to comment that we do have a fork of bifold, but this wallet is not a heavily modified fork of bifold. We had the fork of bifold for some minor stuff, basically for extending customization. But the wallet itself, it uses bifold as a dependency. So it's not like we took a bifold code base and heavily modified it, and we don't have a strategy to contribute this back. So it's basically a separate wallet. We use some components from bifold as a dependency. Some components are re-implemented and integrated with bifold components using dependency injection mechanism that was introduced there. So there is no volume of changes that we've done to bifold itself that cannot be contributed conveniently. I would say it's more about new features that we implemented that we may want or may not want to. I would say it's more like if bifold wants these features and if they are suitable there.
Yeah, understood.
Okay, thanks. Yeah, it's great point.
Thank you for the question. Sorry, very small update from my side that we are going and we are working on some bug fixes to bifold and contributing it when we see them. And also at the same time, products that you saw, like a wallet, like a service part, we are looking right now for opportunities for making this open source to make it possible to use this for the whole community, not only like a framework, but also like a final application with everything that you saw right now. Thank you.
Thank you.
All right, thanks, Renato.
Romek.
Yeah, just a quick question. It's a reasonably smooth transaction you're doing here, but where are the bottlenecks? I saw that the DID was quite slow to actually verify. Is that an example of where things go slowly? So where are the problems here? What needs to improve? So to make it so I have a limit for transactions of about 500 milliseconds in my work elsewhere, and so speed is always important. So where are the bottlenecks in this system at the moment for doing credential checking?
Or checking specifically?
Sorry, credential, the actual transaction itself. So where are the bottlenecks?
Well, I will say that the most long part of all this process, for a good example, is unencrypted issuance, but there is kind of a bottleneck of creating credential definition, just calculating it on a issuer side. So I will say that for creating initial unencrypted resources, schema, credential definition, and writing them to the ledger, I will also say that the bottleneck will probably be, at least in current implementations, I will say that just calculate credential definition will probably be more significant than to push it to HCS in this case, in case of Hedera. So it's a good question, but for read operations, it's a very important point is caching. So caching really helps us to avoid additional requests to the ledger. If the ledger and mirror node in Hedera is very quick, caching still goes with benefits here. And I would say in our SDK, it was an important point of improvement, but it's already implemented and it's quite flexible. So user can provide his own cache. For example, if he wants to use Redis, he can implement an interface and integrate it into the an SDK and so on.
Great.
Thank you.
David?
Just one question about cache. Do you have an events layer that would notify the cache to purge itself of a invalidated or revoked credential?
No, the cache actually works with more like with data that we read from Hedera mirror node. It works with messages. It works with basically with messages and query results maybe from HCS topics. So it's not aware of credentials concepts and revocation concepts.
Okay. Thank you.
Yeah, thanks. And yes, sorry, let's move forward. I want to show you a couple of slides. We have a little time left, so yeah.
Yep.
So yeah, kind of important slide, but it's small one anyway. What are the benefits for communities? So what we see as the benefits of this work for everyone, not only for Hiero community, but for broader identity community. First of all, it's considerations on replacement for Indy. So Sovereign Network, as you all know, reached the end of its service, and it's no longer a default option for decentralized identity use cases. So frequently, we have a question, what new trusted and stable ledger to use? And in terms of open world foundation projects and aca-py and Credo, so many of ecosystems use these projects in production or pre-production environments. And migrating to another ledger, for example, on Hedera, to Hedera, of course, I mean, it's much easier than moving to a completely new agent implementation or SDK. And aca-py and Credo plugins for Hedera provide an option to use a highly performant Hedera network that brings speed and low cost of operations, in this case, to decentralized identity use cases. And it also large trusted network that's successfully used for many other use cases and has large and active communities. So we believe that Hedera will be a great choice for both existing and new identity solutions from this perspective.
Maybe I can just slip this for a second. I mean, I would just say, as you know, as a product manager at Hedera, I mean, I think we love the new plugin architectures. Like, you know, I think, you know, spearheaded by aca-py and all the work that Stephen did, but also now in Credo, like these are ideal for us because we have a large range of customers that are coming to us wanting to implement identity solutions, but they don't want to build it from scratch. And so now we're able to say, hey, please use this open source library. And then just when you configure it, please use the Hedera option. So it's like the best of all worlds for us. Like we get to contribute to open source, but we get support for Hedera in these kind of mainstream prominent open source libraries. So it's really like this. I think we really love this plugin stuff. We'd love to see more of it across the open source environments.
That was a great statement.
Yep. Thank you.
Absolutely.
Was this the last slide, or is there still one?
No, there is a couple, but these are
Okay.
not so important. So most important, what I wanted to share here, development roadmap. So there is a plan for Hiero Identity Workbench project. It's a set of ready-to-use components, enabling developers to try out and conveniently build identity solutions on Hedera. Another significant point is introduction of Hiero Identity Standards repo as a common hosting place for Hedera/Hiero identity specifications, DID, unancreds, DID skid host spec, by the way, there is one, and also a future adoption of relevant standards, so unancreds 2.0 spec, Hedera DID spec 2.0, and further updates. And just about the community activities, first of all, I want to mention that there is a Hiero Identity community meetings planned. I put a registration link here. I will show the slides, of course. It will be monthly. First meeting is on November 13th, this Thursday, basically. And of course, join LFDT Open World Foundation Discord channels. On LFDT, you can find Hiero section. So there are channels related to DID SDKs that I mentioned. And on Open Wallet, please see aca-py and Credo channels. All the plugins and ledger modules related stuff can be discussed there. And there's just some links that will be useful for slides when I share them, GitHub organizations, repositories. Yeah, for SDKs, architecture and implementation details, please see design documentation located in the repo. And of course, links to OVF projects and also to Hedera specifications. And here I had a slide for Q&A, but I think we've already done this, right? And here is just some contact information, mine and Keith. Yeah, any other questions, closing comments?
If there are no closing comments or questions, I can just say that thank you, Alexander and Keith. Very, very solid work. And I'm sure that there will be a lot of interest to talk to you and take this forward. There is so much going on here, so we do need this kind of concrete progress. Thank you.
Thank you very much, everyone.
And that means that we have finished spot on time, and I'm sure that the material that will be shared will be watched closely. There are so many intricate details around that is needed by many. Thank you.
Thank you.
Thank
See
you.
you. Bye.
Closing here. Thank you.